So, quiz 7 is our last quiz for our trig unit, and it's going to begin with a little review of the 45, 45, 90 triangle and the 30, 60, 90 triangle. So we need to remember that 45, 45, 90s are in the pattern. The legs are the same, whatever they are, and then the hypotenuse is the leg value times the square root of 2. So when I look at this, leg times square root of 2 means that each of my legs must be a 6. On a 30, 60, 90, the pattern is the short leg is my x, the hypotenuse is double that, and then the medium leg is whatever the little leg is times the square root of 3. So if 2x is double my little leg, if I kind of think backwards, that means my little leg must be a 4. And then this leg is 4 times square root of 3. Definitely need to review some 45, 45, 90 work for what comes next. We're going to have you draw a strange angle that's not in the first quadrant. Hold on, let me turn off my mic. Off my smartboard. Oh, that was loud. Okay. The cosine of 330 degrees. So remember, 330 degrees would be in quadrant 4. This is 270. This is 360. So 330 degrees would be roughly right here. And we're going to create a reference angle in the triangle from that reference angle. So here's my little right triangle. If this is 330 degrees and this is 360 degrees, then this is a 30-degree angle here on the reference angle. And I'm allowed to set up the ratio of the sides however I want. They're always going to come back to the same 30, 60, 90 ratio. So the little leg I'm going to set up as a 1, and then the hypotenuse is 2, and this is square root of 3. But because of the direction of the quadrant, this is actually a negative 1, even though it's not quite appropriate to call a leg negative, but that's okay. So now the ratio they ask us for is the cosine ratio of that angle, and one formula for cosine is x over r. Otherwise we could use our old adjacent over hypotenuse. So adjacent over hypotenuse would be square root of 3 over 2. And then I always want to do a double check. If I'm in quadrant 4, and I think about the all students take calculus mnemonic device, in quadrant 4, cosine and secant, his reciprocal buddy, should both be positive, and I just calculated cosine, and he's positive, so I'm feeling pretty good about how I used my signs. Let's look at cosecant of 135 degrees. So here's 135 degrees, roughly. This is 135, and this is 180, so if I do a quick subtraction problem to find my reference angle, I can see that this is a 45-degree angle right here. So I'm looking at a 45, 45, 90 triangle. So I can set up my legs however, whatever size I want, because the ratio is always going to be the same. I'm going to call these legs 1, and the hypotenuse is square root of 2, but again, because I traveled left for this leg, I'm going to call him a negative 1. Cosecant is a couple different formulas. We could do hypotenuse over opposite, or we could do r over y, and square root of 2 over 1 is just square root of 2. And again, I think about my mnemonic device. I'm in quadrant 2. Cosecant and sine are the only positive functions, and I just got a positive answer, so I'm feeling like I did it right. Okay, now we're going to graph. So bear with me while I try to graph on the tablet. 2 times the cosine of theta over 2. So first thing I notice is the amplitude is now a 2. And remember, if you're in charge of the axes, so if you want to label them something other than 1s, that's fine. Oh goodness, it's getting worse. Okay, pretend that was straight. The other thing I need to calculate is the period, because it's changed, because we have a theta over 2. That's the same thing as 1/2 times theta, so my b value is a 1/2. Remember, we can calculate the period of a trig function, sine or cosine, by taking 2 pi and dividing it by the b value. So 2 pi divided by half is really 2 pi times 2, which is 4 pi. So now, I'm going to realize I'm going to mark off every quarter point. I'm going to take the period, 4 pi, divide it into quarters, which means I'm going to mark off every pi. So I'm going to kind of jot it down here. Starting at 0, I'm going to mark off 1 pi, 2 pi, 3 pi, and we're actually going to run out of room. We're not going to be able to graph it all in this direction. Cosine starts at the upper line, then goes to mid, lower, mid, upper. I'm going to graph everything I can. 0 on the upper line, pi on the midline, and then I would have graphed, let's say 2 pi on the lower line. And there's more I could be able to graph if my graph extended that way, but I'm kind of going to use the pattern and go backwards now. Looks like we're counting off 4 every time, so this would be my next point on the midline, and this would be my next point on the lower line, and we're going to see a very stretched out, oh geez, oh gosh, there you go, cosine graph. And remember our little rule about the b value. By the time I hit 2 pi, from 0 to 2 pi, I only went through half of a cycle of cosine, which is what that b value represents. Same thing on 5 for the amplitude. ugh, geesh. Sorry, 2's. And then the b value is a 2, so the period, instead of 2 pi, it's 2 pi over 2, which is just going to be pi. So if I try to calculate my quarter points, I take pi and cut it into quarters. So I'm going to mark off every pi over 4. Starting at 0, I'm going to mark off 1 pi over 4. And if you're afraid of the fractions, just don't reduce them. You could keep it as 2 pi over 4, 3 pi over 4, and 4 pi over 4. And then 0 with sign starts on the midline, upper line, midline, lower line, and midline. So 0 on the midline. Pi over 4 would be in between pi over 2 and 0, so upper line, midline, lower line, midline, and I'm okay if you just graph one cycle. They technically want you to graph over the entire domain, so you would just continue that pattern, but as you can see, my graphing is limited. Okay, number 6. This shift means that we have a vertical shift of down 3, which also means my k, my midline, is now at -3. So here's -3. That's my new midline. My amplitude, however, is still a 1. That has not changed. So my upper line is now here at -2. That's kind of weird. And then my lower line is at -4. Oh, jeez. Okay, pretend it's at -4. The period has not changed on this one. There's no b value other than 1. So the period is still 2 pi. And when I go to find my quarter points, take that period and cut it into quarters, which reduces to pi over 2k. So starting at 0, we're going to mark off 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. So 4 pi over 2. Again, reduce them if you're comfortable with it. And sign starts on the midline, upper, midline, lower, midline. So at 0, I should be on the midline. Remember, my midline is now down here at a -3. Pi over 2 upper, pi midline, 3 pi over 2 lower, and 2 pi midline. And then I kind of step back and look at my graph and I say to myself, does that look like a sine graph that's been shifted down 3 units? And I say yes, so I'm good. Number 7, instead of having a vertical shift, now we have a horizontal shift. And remember, inside the parentheses is always kind of opposite of what you think. So this particular function is shifted right pi units. So I'm going to use these same green points because the period hasn't changed at all. However, pi over 2, I'm going to leave it as 2 pi over 2, 3 pi over 2, and 4 pi over 2. If I'm going to shift everything right, that means I need to add a pi to each one of these because my new markings are going to be shifted. It doesn't change my upper, middle, and lower, it just changes where their x value is located. So my new marking is going to start at pi, and then let's see, that's 3 pi over 2. Use your calculator if you're not comfortable with adding the fractions. 2 pi, excuse me, 5 pi over 2, and 3 pi. Remember, we are supposed to be graphing a cosine, so this first point is going to be the up line, midline, lower line, midline, and upper line. Let's try this. I did not mark off my amplitude lines, apologies. So at pi, we're going to be graphing on the upper line, say that was right here. At 3 pi over 2 on the midline, at 2 pi on the lower line, and I can sense a pattern. We're going 2 blocks each time, so I'm going to kind of back up with the pattern. There we go. So it's kind of difficult to tell on the horizontal shifts, but if you kind of envision your cosine graph beginning right here, even though it didn't finish, it does seem to be shifted right pi units. So I'm thinking we did pretty well there. Now we're going to simplify some trigonometric expressions. This one's kind of interesting because sine squared plus cosine squared, whenever I see that on a piece of paper, I know that that equals 1, so I'm going to replace everything in that blue box with a 1. And then this is the one where I always forget the trade. So let me cheat. 1 plus cotangent. Oh, that's just cosecant. So one of those Pythagorean trades. I forget how it started. I think it was 1 plus cotangent squared, actually. he equals cosecant squared, so that means I could trade one side of the identity equation for the other. So he's equal to cosecant squared. And then tangent divided by sine. I know tangent is really sine over cosine. And then I'm going to write this division like a 5th grader. I'm going to say I'm going to divide it by sine. Well, I know when I divide, I'm actually multiplying by the reciprocal. So I'm going to change this to multiply by 1 over sine. And that works out kind of beautifully because the sines will cancel and they end up with 1 over cosine. But that's still not simplified enough because 1 over cosine is actually secant of x. That's more simplified. And then here we're going to verify the identity. I feel much more comfortable verifying because I know when I'm done. Cosecant is 1 over sine. I'm going to trade for that. Minus cosine, I'm going to put it over 1, times cotangent, which is cosine over sine. So first step, just trade out for cosines and sines. Now we think about algebra. I have cosine times cosine on top of that fraction. So right now I have 1 over sine minus cosine squared over sine. And I notice that my fractions have common denominators, which means that I could write them as one fraction. So up in my numerator, I really have 1 minus cosine squared over the common sine. Well, this is great news because 1 minus cosine squared is that Pythagorean trade. He's equal to sine squared. So if I take sine squared and divide it by sine, I get sine. Remember, the last step in your identity has to be the identity. Sine x equals sine x. And notice I didn't change anything along the right-hand side here. Remember to update your foldable with all of your trig trades, and that is your preview.